Today, let's talk about a topic related to the sun. Did many suns really exist in the ancient times? This conclusion may be true. In the classic of mountains and seas East Shen Hai Jing, there is a record of an ancient legend. Nowadays, more and more experts believe that the classic of mountains and seas does not record mythological stories, but rather real situations from ancient times such as history, geography, culture, customs, and so on. The book mentions that in ancient times, there were 10 suns on the earth, and they rested on a tree called Fu Sung. Every morning, a giant three-legged crow would carry a sun into the sky, completing the task of illuminating the earth. By evening, this crow would bring the sun back to the Fu Sung tree, and the next day another sun would come out to illuminate the earth. In this way, 10 suns took turns on duty, maintaining the alternation of day and night. However, this harmonious situation was disrupted by a great battle of gods and demons. The evil demon king deceived the 10 suns, causing them to appear in the sky simultaneously, which scorched the earth and brought suffering to living beings. To save the world, the great hero, Hu Yi, stepped forward and prepared a divine bow to shoot down 9 of the suns, leaving only one, thus restoring the world to its original state. Hu Yi was a handsome and courageous hero at that time. Seeing the people suffering under the threat of multiple suns, he was determined to save the world. So he decided to step forward and rescue humanity from dire straits. One morning, Hu Yi arrived under the Fu Sung tree with a divine bow and a bag of divine arrows. The Fu Sung tree was tall and majestic, with dense branches and leaves, hosting those 10 giant sun crows. Every morning these crows would carry a sun into the sky to illuminate the earth, and in the evening, they would bring the sun back to the Fu Sung tree. Hu Yi waited for several days until one morning, the first crow carried the sun up. He drew his divine bow, and the arrow shot across the sky, precisely hitting one of the suns. The sun fell like a fireball, darkening the sky and lowering the temperature suddenly, causing people to cheer and rejoice. However, 9 suns still hung high in the sky. Hu Yi knew this was just the beginning. He shot 9 arrows in succession, each arrow piercing the sky like lightning and knocking down one sun. With the fall of each sun, there was jubilation on earth, and living beings could breathe again. Finally, only the last sun remained. Hu Yi gazed at the sky, knowing that this shot would be the most crucial. He drew his divine bow to its fullest, focused his mind, and shot towards the last sun. The sun instantly lost its radiance and fell to the earth, plunging the entire world into silence. With the fall of the last sun, the sky regained its clear blue. People knelt before Hu Yi, thanking him for bringing light and hope to them. Hu Yi, because of his heroic deeds, would forever be remembered by people. In fact, many of us have heard this story. But interestingly, such legends of multiple suns are not only found in ancient Chinese literature, but also recorded in the cultures of other ethnic groups around the world. For example, Maya culture, ancient Indian mythology, and legends of the Maya ethnic group in Western Hunan all mention multiple suns, albeit with variations in the number of suns described, such as 12, 10, or 2. For instance, on the Babylonian stele in the Louvre in France, there is a striking depiction of 2 suns. Does this mean that ancient civilizations collectively influenced the belief in multiple suns? Modern astronomers believe that indeed there may have been 2 suns in ancient times. Discussing astronomy and geography, talking about strange and bizarre things, this is Jack's Mysterious Affairs Office. If you like this channel, please like and subscribe. In the 1980s, scientists were surprised to discover that species on Earth seem to experience large-scale extinctions at regular intervals. Paleontologists have confirmed 5 major extinction events in the fossil record, each causing a significant reduction in Earth's biodiversity. The first mass extinction occurred at the end of the Ordovician period 440 million years ago, resulting in the extinction of Itexus, of marine species. The second occurred at the end of the Devonian period 360 million years ago, causing the disappearance of about 75 species. The third occurred at the end of the Permian period 250 million years ago, which was the most severe, resulting in 90 cases of species extinction. The fourth occurred at the end of the Triassic period 210 million years ago, leading to the extinction of 80 of species. The fifth occurred at the end of the Cretaceous period 60 million years ago, which caused the complete disappearance of dinosaurs from Earth, along with the uncertain fate of 70 of other species. However, what caused these repeated mass extinction events, if it was only natural forces, such as volcanic eruptions, earthquakes, hurricanes, floods, or diseases? It seems unlikely that such large-scale biological extinctions could occur. Therefore, astronomers have attempted to find reasons from extraterrestrial disasters, especially catastrophic impact events. 1994 was a significant year for astronomy. On the night of July 16, fragments of comet Shoemaker, Levy 9 collided with Jupiter's atmosphere at an astonishing speed of 210 kilometers per hour, causing a massive impact on Jupiter. In fact, this comet had already fragmented due to immense tidal forces when it was 40 kilometers from Jupiter. Nevertheless, the largest fragment, known as Fragment G, still had a tremendous impact on Jupiter, equivalent to an explosion of 6 million tons of TNT, leaving a scar in Jupiter's southern hemisphere larger than Earth. So, what does 6 million tons of TNT mean? Its power is equivalent to 750 times the total explosive yield of all nuclear weapons on Earth. But this is nothing compared to the asteroid impact that caused the extinction of the dinosaurs on Earth, which produced an explosion equivalent to 100 million tons of TNT. At that time, a paleontologist named Longpino looked at the new scars on Jupiter, and then looked at the ancient meteorite craters on Earth. After calculating with the computer, he found that every 27.5 million years, the Earth will suffer a fatal impact event like this. If this theory holds true, the number of times Earth has been destroyed is far more than just 5 times. In 1990, Mahler, a physicist at the University of California, Berkeley, proposed a point of view, suggesting that there is a brown dwarf star 1.5 light years away from Earth, which may be the culprit behind the large-scale biological extinctions on Earth. Brown dwarfs are a type of relatively dim star, emitting light typically in orange or red hues, making them difficult to observe directly through telescopes. Brown dwarfs generally have sizes about 10 to 15 larger than Jupiter, but due to higher density, their masses range from 13 to 80 times that of Jupiter. Upon Mahler's proposition, it immediately sparked widespread attention in the academic community, and the hypothetical brown dwarf was named Nemesis. In ancient Greek mythology, Nemesis' role was to punish humans who offended the gods. In Greek mythology, she is known as Nemesis. Many might not have heard this name, but her daughter, the Greek beauty Helen, who triggered the Trojan War, is more familiar. Subsequently, Mahler deduced Nemesis's orbital path, which involves a dance with the sun. But how does it wipe out Earth's life forms in the process? Mahler speculated it might happen like this every 27 million years. Nemesis approaches the Oort cloud, a period coinciding with major extinctions on Earth. The Oort cloud lies in the outer reaches of the solar system, a spherical cloud filled with frozen dust and unknown objects. Himmler theorized that Nemesis's immense gravity disrupts this region's balance, causing large comets and asteroids to veer off their orbits and head toward Earth. Eventually, a celestial body might inadvertently collide with Earth, triggering periodic mass extinction events. Once the prime suspect was identified, efforts turned to finding Nemesis. To verify this hypothesis, numerous astronomers joined the search for Nemesis. However, decades passed without success, leading to doubts and eventually splitting into two camps. One camp believed M. Blair's hypothesis was unrealistic and that Nemesis does not exist. The other camp persisted in the search, arguing the hypothesis was plausible but required further exploration. Finally, in 2017, astronomers from the University of California, Berkeley, led by Stelter and his team, made a new discovery. They found a massive molecular cloud in the constellation Perseus, 600 light years from Earth, rich in hydrogen and characterized by low temperature and high density. These conditions are essential for star formation, leading to the birth of numerous new stars within the molecular cloud. Stelter subsequently discovered these newly formed stars often appear in twin pairs. The distance between these twin stars is about 500 AU, and AU is approximately the distance from Earth to the Sun, and 500 AU equals about 17 times the distance from the Sun to Neptune. Over time, these emerging twin pairs either draw closer, forming true binary star systems, or drift apart, eventually becoming independent stars after millions of years. This discovery prompted Stelter to consider Nemesis. Could it have been born as a twin with the Sun? If true, our solar system may indeed have had two suns at one time. So, where could this companion star be? Turning back to the 19th century, a Danish astronomer named Hansen was diligently searching through telescopes as he noticed mysterious disturbances in Uranus's orbit. Uranus is the third largest planet in the solar system and 14 times the weight of Earth. Such a colossal body should not be easily disturbed by ordinary celestial bodies. Thus, Hansen deduced two stars of similar magnitude must orbit near Uranus. Sure enough, astronomers discovered Neptune in 1846. Was Neptune the disruptor? Before astronomers could conclude, they noticed disturbances in Neptune's orbit as well. Thus, astronomers suspected another large planet must exist near Neptune. Finally, their research focused on the Kuiper belt, near Uranus and Neptune, abundant with asteroids and other celestial bodies. The Kuiper belt is considered one of the earliest remnants of the solar system's formation, potentially harboring clues to Nemesis. However, due to its vast width and great distance from Earth, current technology makes it challenging to discern what kind of celestial body might reside within, so directly pinpointing a second sun from the Kuiper belt poses great difficulty. Therefore, astronomers attempted alternative methods to indirectly prove Nemesis might reside in the Kuiper belt. At this point, a dwarf planet named Comet caught the attention of astronomers. What makes a dwarf planet special? Firstly, it's larger than asteroids. Secondly, it doesn't have its own independent orbit, but shares one with other celestial bodies. Normally, the Kuiper belt contains many dwarf planets, so Cetna's presence isn't extraordinary. However, Cetna's unusual trait lies in its extremely long orbital length of 11,390 years. When closest to the Sun, Cetna reaches 70 AU, and at its farthest, it extends to 930 AU, resulting in a portion of its orbit lying within the Kuiper belt. This elongated orbit is believed by Nemesis supporter to be caused by a massive celestial body within the Kuiper belt. tugging at Setna. This body likely represents Nemesis, the second sun that once existed in our solar system. Well, that concludes today's story. Thank you for watching this episode. Creating these videos isn't easy, so please give it a thumbs up to show your support. If you'd like to watch more episodes, click on my profile and bookmark it. See you next time. Bye bye.